Well, it's good to be with you again today as we start into our second section. Let's look at our advanced organizer so you know what's coming today in our lesson. For your materials, if you happen to have a property survey that would correlate with the lesson, that's just something optional. And then activity 1-3, find it, will be used. And then we're planning today to spend a few minutes reviewing. And then we'll be talking mainly about the geographic grid. That's our topic for the day. And then our activity is slicing an apple. So if you have one and you want to slice it, that's fine. Or you can just watch me as I slice. The main idea for our geographical grid today is that latitude and longitude allow us to find the location of any place on Earth. And our goals are to locate places on a map using latitude and longitude. So that's our only goal for today. It might be something that you're already aware of and that you can do well, and or it might be something that you need a little bit of brushing up on. Let's start out our class today with our theme verse for this chapter, Isaiah 45:18, and read this with me. For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it. He created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else. All right, and the first thing on our agenda is to review. So I want to find out what you remember from our previous section. Now, I taught about it, and then you read about it, so that should have been a review in a way. And then you had your section review. So if you did those things, this should be no problem for you. It is a little bit different, though. It's a multiple true false. So we'll have two statements together, and you have to determine, are they both true? Are they both false? Is one of them is the first one true and the second one false, or the first one false and the second one true? So there's 4 different answers that you could give. Ready? Let's review. Geography is the study of the earth. Geography means description of the earth. So both true, both false, first true, second false, or first false, second true. Those are your choices. Okay? Those are both true. Geography is the study of the earth, and we know that the term comes from 2 words meaning earth and description. One main branch of geography is physical geography. Another main branch of geography is systematic geography. Okay? True and false. Did you answer true and false? The first one is true. Physical geography is a main branch. The second one, though, however, is false because systematic geography is not a branch of geography. It's a method of study. Remember, we have our physical and human geography. Those are the 2 branches. And then the methods of study are systematic and regional. Okay, here's our next pair of statements. Mercator was one of the greatest ancient geographers, and Copernicus was another ancient geographer. All right, both false. I hope I didn't catch you on that one. Both Mercator and Copernicus lived during the age of exploration, not in ancient times. Do you remember who were the most famous ancient geographers? The greatest ones? Eratosthenes. Remember, he calculated the circumference of the earth, and Ptolemy generated a world map and promoted the geocentric theory. Okay, a couple more. The geocentric theory promoted by Ptolemy is still in use today. And Mercator's grid, which enabled sailors to plot their courses in a straight line, is still in use today. Okay, that one is false and true. The geocentric theory is not still in use today. It was promoted by Ptolemy, but not in use today. And Mercator's grid is still in use today. Okay? Ancient maps exaggerated Asia and did not show the Western Hemisphere. And modern maps can show great detail due to technology such as radar and infrared satellites. Okay? True and true. Both of those statements are true. Okay, and that wraps up your review. Now, did you notice that all of those answers were from your section review that you were to complete? So that should give you an idea of whether you got your section review answers correct or not. I want to take just a moment to give you some hints for using those section reviews, okay? Now, here I have just the section review that we basically went over everything that was in this section review, and this is what was assigned to you. Now, I typed mine. You might write longhand, or if you like to type, you might want to type it out. But notice for number 1, geography, dash, the study of the earth. That's what I first wrote. Then, okay, I saw, what can I write from memory? The study of the earth. Then I looked in the textbook and saw that the textbook said a detailed description of the earth, especially its surface. So I added that in. Okay, then I have 2 main branches, human and physical geography. And this is much more helpful than just writing things like human and physical, yes and no, Eratosthenes and Copernicus, because it doesn't tell you anything about those people when you go to review. This way, I have all of the information right here. I know who the greatest ancient geographers were because I wrote down. Now, you don't have to write the whole question. You don't necessarily have to write your answer in sentence format. But if you just put a little idea of what the question was and then your answer, that can be very helpful when you go back to study. Some people do like to use the textbook, but I like to have mine just all on one sheet of paper so I'm not flipping through the book. Where was that section review and where were my answers to it? And you might even want to put part of the answer on one side, or part of the question on one side and the answer on the other. You can fold that in half and use it later as a study guide. So when you do those section reviews, don't just think of them as, oh, this is just an assignment I have to do, but think of those as a study tool as you answer those section review questions each evening. Okay? Now, we also had a thought question, and that was at the end of your section review questions. It wasn't numbered, but it had that little light bulb next to it. That stands for ding, you know, when the light comes on. And the question was about the United States. Why has the United States become the leading map maker? So hopefully you're able to come up with a few ideas on that. I'm going to tell you just a couple general reasons. First of all is our military and our international military obligations. That was one big reason for making maps, so people knew what lands they conquered and what they were settling and where their armies were marching. And another reason is that in the modern times of geography, there has been a great turn to technology in helping us to make maps, and the United States is a leader in advanced technology, so that those two elements really lend themselves to the United States being the leader in map making today. Now, in our previous lesson, we did talk about ancient geography. Started out with that. Then we went to the Middle Ages, the Age of Exploration, and the Modern Age. And then we ended up talking about the future of geography. And I had to cut that pretty short last time. But we need to remember, in all honesty, really the Age of Exploration is not over. We did go from that time period into the modern time period, and of course there's a future. But geographers are making new discoveries about the Earth all the time. And that forces us to update some theories that we thought were true, or overturn some time-tested theories. Okay, think about Ptolemy and his geocentric theory that the Earth is the center of our solar system. That went unchallenged for 1,400 years until people began making new discoveries. Now, others did have other ideas, but they weren't generally accepted. And those type of things continue. Maybe not anything as revolutionary as the fact that the Earth isn't the center of the solar system, the sun is, but there are new discoveries every day, or I would say probably every day, but at least every year, and the field of geography is constantly changing, and it is indeed a very current study. So that's why we're going to be keeping a current events notebook this year. Okay, for your current events notebook, the first thing you need to do is find an article about a recent geographic development in exploration. Now, your article can come from a magazine or a newspaper, or you might have access to the internet where you could get an article, and you want to either cut that article out or print it out, copy it, type it out, print it out, and save that on your notebook. And I have an example here. I just printed mine You don't need to read the article, but this is just a little format. Here's the title of the article, and then I just copied and pasted the article. All right, then you want to include a few things in particular, and that is, well, first of all, you put it in a notebook. You want to note the title, the source, where you got it, what magazine or what site, and the date, and then write a brief summary of the article below that. You can see here on mine, I have the source, it's just an internet address, then the date of the article, it's not brand new, and then the summary. And notice the summary is real short. It doesn't have to be very long. You just kind of summarize what's there in the article. And you might come up with an article that's a lot longer than that, and you might need to have a longer summary. But that's what you'll be doing for your current events notebook. And we'll look for something every chapter at least, and you might find things other than what is assigned. When you're looking through magazines or newspapers, you might find something that's related to a topic that we've been studying. All right? Now that brings us to our lesson topic for today, the geographic grid. Do you remember our definition of grid we learned in our previous lesson? Okay, a grid is simply a regular pattern of intersecting vertical and horizontal lines. But what is the significance? Do you recall? Why is the grid important? Okay, because it makes locations easy to find on a map. And not only does the geographic grid make places easier to find on a map, it also enables us to accurately pinpoint specific places on the Earth itself.
Apollo 11, this is Hornet, over. Apollo 1, this is Apollo 11. Roger, our position 1330, 6915.
How would the naval ships be able to find the astronauts in their capsule after splashdown in the vast Pacific Ocean? It's a huge area. Well, they used the geographic grid to pinpoint the astronauts' location. And that's what we're going to be learning about today, the geographic grid. And we're going to start by defining that. The geographic grid divides the Earth into hemispheres, and using latitude and longitude. And we're going to look first at the hemispheres, and this should be a review to you because you should already know what a hemisphere is. But just as a review, a hemisphere is half of the Earth, and my question to you is, how many hemispheres are there? It's a trick question. There are 4 hemispheres. And you're like, wait a minute, 4 hemispheres? I thought half of the Earth, if you have something, there are only 2 parts. But remember, we divide the Earth in 2 ways. We have our northern and southern hemispheres divided by the equator, and our eastern and western hemispheres divided by the prime meridian. And we're going to use an apple today as an example of the Earth. I have several just in case. I was afraid I might mess up trying to slice my apple. But this is going to be our example of the Earth. And we're going to slice it first across the equator. All right, so just like this. Not exactly straight, but bear with me. It's an imperfect Earth. Okay, so this cut's going to represent our equator, and then this would be our northern hemisphere, and this would be our southern hemisphere. Okay, and then our other apple, we're going to take and slice it the other direction to represent our eastern and western hemisphere. So that's going to go right down through our North Pole here. Hopefully. So this represents our eastern and western hemispheres sliced along the prime meridian and the matching meridian. Okay, and we're going to come back and use those a little more during the lesson as an example. Now, because the Earth is a sphere, it's easier to measure in degrees, just like we would a circle. So if you think of our apple, it kind of looks like a circle after you've cut it, either direction. It looks kind of like a circle. And so it's easy for us to measure it in degrees. And our degrees are latitude, degrees of latitude, and latitude runs east and west. It forms circles parallel to the equator, so the circles will never intersect. That's why they're called parallels. And they're measured from 0 to 90 degrees north or south. And so we're going to use our apple to cut more parallels. I'm not going to cut too many. I want to cut myself right here. I already cut myself making a peanut butter and jelly sandwich this morning. How a person could do that, I don't know, but I managed it somehow. I'm dangerous. All right, so that's representing our parallels. Cut a few more slices over here. So the parallels are never going to intersect. They're parallel to the equator. And you see how they run east to west. Okay, they're running, oops, stack my apple back up again. They're running what would be east to west. Okay, here's our east, here's our west. But they're measured north to south. When you're going up, north, and when you're going down, south. Now, they're only measured from 0 to 90 degrees. Why do you think that is? It's kind of unusual, isn't it? Because our measurement is actually going to show only a quarter of a circle. I don't want that to be confusing to you, but they have a really good illustration of it in your book on page 6. So let's look at that together. Go ahead and turn to page 6, and you can see here is our equator, and the parallels, they're the rest of the parallels, they're measured from the equator. So the farthest away you can go is up to the North Pole, and what angle does that form? A 90-degree angle. And so they cannot get any higher than 90 degrees. So, because if you come down here, it's going to be less than 90. If you come over here, that's how we measure it. So that's latitude 90 degrees. This is 0, this is 90. Then, say we want to come over here and measure. We actually measure the angle. Okay, if we measure that angle, we draw our line straight across, we get 57 degrees. Okay, if we got the same point over here, it would be 57 degrees. We draw our line between those 2 points. That's our 57 degree north latitude. All right, so those are our latitudes. Now, there are about 69 miles between each degree of latitude. So to be more accurate, each degree has been divided into 60 minutes, and each minute into, take a guess, 60 seconds, just like time. And this is an example for you. Can you read that? It's kind of a big, long one, but it's 48 degrees, 56 minutes, so the one little mark there, like a foot mark, is the minutes, and 32 and 121 thousandths seconds. So the seconds, you can see they've divided those even into the decimal places, and then the double quote, or the quote looking mark there, or the inch looking mark, that is for our seconds. So let's practice just a little bit. 48 degrees, 56 minutes, 32 and 121 thousandths seconds. And how many minutes would be in half a degree? Okay, think of the clock, 30 minutes. Okay, how many minutes in 1/4 of a degree? 15 minutes. How many seconds in half a minute? 30 seconds. And one more, how many seconds is 3/4 of a minute? 45 seconds. So that's just a little refresher there, a little practice with that. So it's done just like you would think of using your watch and your clock as far as dividing up those degrees, minutes, and seconds. Now the degrees of longitude are divided in the same way. Our degrees of longitude run from north to south. They run north and south. They form great circles intersecting at the poles. And you can see a great circle, or great circles, are lines that divide the earth into 2 equal parts. Okay, now are any lines of latitude great circles? Here's my apple. 2 equal parts? It would be just the equator, wouldn't it? Mine's not exactly equal. Just the equator would be a great circle, and all of the other ones are smaller, and they divide the earth but not into equal parts, not in half, so they would be considered small circles. That's pretty easy to remember, great circles and small circles. All right, then Our lines of longitude are also referred to as meridians, named after the prime meridian, which runs through Greenwich, England, and it's the basis for all the other meridians. Now, the equator, because of the angle of the Earth and the rays of the sun, the geographers were able to locate the equator thousands of years before the prime meridian, because they could find it due to the seasonal changes, the angles of the sun's ray. The prime meridian, however, there's really nothing to distinguish the meridians, so I don't want to say it's necessarily arbitrary, but there was a royal observatory there in England, and so they chose a line and they drew that line, and all the other meridians are based on that line. So I'm going to go ahead and slice our earth apple. Woo! I got him close now. Sorry about that. Slice our earth apple into meridians, or lines of longitude. I'm afraid to slice too many, but I better just stick with 4. What do you think? Ew, not a very good apple. If I go much more than that, it's going to be very difficult for me. But now, what are the differences? What differences do you see? Here are our meridians, and here are the parallels. The parallels are parallel, they don't intersect. The meridians do intersect. Where? At the North Pole and the South Pole. Okay, so that's a difference. And each set of meridians, a meridian just goes this way. This is the prime meridian, and then this could be the matching meridian on the other side. My earth is falling apart. Okay, but the meridians all form great circles. I can take the apple this way, it's a half. Or I can take it this way, it's a half. And if I cut a bunch more, you could take it apart and still have half. So every meridian is a great circle. Okay, so that's something important to keep in mind. The meridians also have to do with the time zones, because of the Earth's rotation. So the meridians mark the time zones, and they're marked 0 to 180 degrees east or west, because the meridians show half a circle. If we look back to your textbook on page 7, remember how our latitudes show a quarter of a circle? Well, the meridian shows half a circle. See, here's our prime meridian. Okay, and if we go around the Earth as far away from the prime meridian as we can get, it's still only halfway around, right? Because the whole circle is 360. So we're going from 0 to 180. And then it starts back down again. All right? And they're labeled east and west. 30 east, 30 west, 60 east, 60 west, 90 east, 90 west, and so on. All the way up to 180. Okay, so there are a lot of differences between our meridians and our longitudes. So we need to keep that, you want to keep those things in mind. And another difference is, with our parallels, we have our North and South Pole, but they're not intersected. Why didn't we cut the apple like this? Why didn't we intersect with the parallels? There are no poles on the sides, are there? There are no east and west poles to run through. Instead, we have the equator. Here, we have the poles as our base. You know, we cut through the poles. Okay, so that's just one more difference. Now, the distance between each degree of latitude is 69 miles. What do you think the distance between each degree of longitude is? Okay, I hope you paused the program to think about that. It was kind of a little trick question. Remember that meridians are not parallel. So the distance between 1 degree of longitude, between the longitudinal lines, varies from 69 miles at the equator, okay? So here they're going to be 69 miles apart, to less than an inch near the poles, because remember they intersect. So they're right next to each other. In fact, visitors at an American Research Center at the South Pole can actually walk around all 360 degrees of longitude in just a few seconds. And as I mentioned earlier, longitude is actually linked to time. The Earth turns 15 degrees per hour, or how many degrees in 24 hours? Do you know? You shouldn't have to figure the math on it. It does a full circle in 24 hours, right? So 360 degrees. So the time zones are set up to along with the meridians. So every 15 degrees is a time zone change. This is on page 303 of your book, and I don't think I can show the whole thing and get close enough to show the numbers as well. But here are our meridians marked in 0, 15, 30, 45, 15-degree increments. And then the time is marked at the bottom in 1 hour. So every 15 degrees, an hour is added. The prime meridian is at 0, or say we pick 12 noon. 15 degrees further is add an hour, 1 o'clock. 15 degrees earlier is less an hour, or 11 a.m. Okay, so those are connected with the time zones, and we'll be learning more about that later in the year. But the main thing is to be sure not to confuse latitude and longitude. So let me give you a few hints to help you keep them straight. Okay, for latitude, you can think of something like lattice or a lateral pass going across. Lats, which are short for latissimus dorsi, the lateral muscles. You might think of wide mouth when you say latitude. Your mouth kind of goes wide, and wide like this latitude. Or you can think of ladder slats going across that you climb up on. For longitude, you might think of long johns going down your legs, or a long face. Somebody's a long, narrow face. Longs, which are those long muscles going the other direction. Think of a tall mouth, or a long neck like a giraffe or a goose. But your longitude is going this way, so think of long neck or long face or long mouth, and your latitude is going this way, so think latitude, ladder, or whatever it is that you need to think of, so that you don't get those two confused. Now, surveyors are able to find latitude and longitude easily if they have the right information. They can use the correct Greenwich time and the angle of the sun above the horizon. Then, or they can also use the North Star. Then they can use prepared charts and tables to find the exact latitude and longitude. When they surveyed America, and by survey we mean just to measure land, they set up principal meridians, which is a base meridian for a township, and they measured out acres, which are 8 by 10 lengths. And you'll be reading about that more in your textbook today. But first I want to practice, just get you started on an activity using latitude and longitude. This is activity 1-3 from your book. And let's start out and just do a couple together. You're going to find 20 south, 140 west on the map and determine what it is. Okay, be locating right now 20 degrees south, 140 degrees west. You can use the map at the beginning of your book there. And here's our equator, 20 degrees south, and from the prime meridian, 140 degrees west. Follow those along till they meet, which is down here in the Pacific Ocean. Now for your assignment today, you need to go ahead and read pages 5 through 7, complete the section review on page 7, and complete activity 1-3 as well. As you read, try to figure out, why didn't surveyors just put the Meads Ranch marker at 40 degrees north? And our answer to our where in the world question, the coldest place on Earth, is actually in the atmosphere, the troposphere above the equator.